talk about is interpreting extrema and end behavior. So when we're interpreting a graph, it also involves showing where the function is increasing, decreasing, positive or negative, and where the function has any extreme values, either high or low. Okay? This increasing or decreasing, we've already done this. If you remember back to 1.6, we were talking about when we had these graphs. We look at when they increased, what was happening, things like that. Okay, positive or negative is pretty easy. Extreme values, we can kind of tell, like if we had a graph and we had it look like that. Obviously, we could determine the highest point. That's what an extreme value is. You could identify something like the max. But all of this is going to be relatively simple. We've got this table here. It's a lot of words to kind of say what you already know. So a function is positive when it's above the x-axis, negative when it's below. It's increasing when it's going up, decreasing when it's going down. Okay, this is kind of common sense. The thing you might not know is these extrema. A relative minimum is when you've got a low point, so it's lower than all the other points around it. A relative maximum is when it's higher than all the points around it. And what I really want you to see here, a relative minimum doesn't have to be the lowest point on the graph. It just has to be the lowest point around it. Okay? Just like the maximum doesn't have to be the highest point. It's just the highest point within a certain range. Okay? And there's not really a rule that you have to look between a certain set of numbers. Just identify if there's a point that seems low compared to all of them around it, that would be a relative minimum. If there's a point that seems higher than all the points around it, it's a relative max. End behavior is exactly what it sounds like. What happens at the ends of my graph? As I go to the left, it's just going to keep going up. So I can say as x decreases, y increases. On the right side of my graph, I just keep going down. So as x increases, y decreases. But overall, this seems like a very complicated table, but definitely two of these things are pretty straightforward and common sense. And the last two aren't terribly tricky. So we're going to look at this graph and we're going to interpret any extrema and end behavior. So we've got US retail sales of video games from 2000 to 2009 can be modeled by the function graphed at the right. Estimate and interpret where the function is positive, negative, increasing, decreasing, the x-coordinates of any relative extrema, and the end behavior of the graph. So we need to know where it's positive and negative. Then we need to say where it's increasing or decreasing. And then I need the x-coordinates of any relative extrema and end behavior. And you don't necessarily have to go through and write all these things down, but I can kind of see it's positive all the way when it's above the x-axis, so positive would be black, and it's negative when it's below the y-axis, so that's where I'd have my negative. So you could say it's positive from about 1999, since this is years since 2000, to about 2010, and then it's negative before and after that. And then where is it increasing? Well, it's increasing from, it's going up from the beginning to about 2008. And then it's decreasing after 2008. And notice, this doesn't say 8, but this says 8 years since 2008. So that would be 2008. And then my relative extrema, I've got not really a max there, kind of, at 2002. But the one I'm really concerned about is at 2008. I've got a max, relative max, at 2008, because that's my highest point. And there were about here's $16 billion in sales. So this would be about $21 billion in sales. And then if I look at my end behavior, obviously as the years increase, sales go down. But the main thing I'm concerned about is we've identified all these things. I want you to kind of be able to tell me what happened. Well, we can see sales kind of peaked around 2008 and then they went down. And this graph is very misleading, and here's what I want you to see. When we have a limited amount of data, we can be very easily confused by a graph. Because all we know is that sales were going down probably in 2009 and 2010. And there's probably plenty of you that still play video games, and you would know video game sales have probably gone back up. But because we stopped at 2010, the end behavior looked like sales were just going to keep going down forever. And that's one thing I want you to be cautious with end behavior. Just because it looks like it on a graph does not mean it's necessarily true. It's just true for the data that we have so far. But a lot to identify, but we can kind of look at this information. It helps us know what was going on. Okay? They were making sales between 2000 and 2010, which makes sense because we went 2000 to 2009. And it basically went up every year except for 2009. We started to go down, which is why our graph looks like it went down forever. But we know probably after 2009, sales went back up. Little confusing one to end on, but as long as you understand these individual pieces, it's not so bad. As always, let me know if you have any questions.